All right, good morning, everybody. I hope you all had a great weekend. Hopefully some of it was filled with some math problems. Make sure you're keeping up with all of that stuff. Just a quick reminder to make sure you're muted as we get started. And that you have the chat open on the side so that way you can ask questions or see what other questions people are asking. So the plan for today, there are, as you saw, you got assignment 4 feedback over the weekend, assignment 3 feedback as well. So basically we're going to take a look at 1 or 2 of those questions, and there are some general issues that I saw between the classes of things that I want to clarify on a bigger scale. So I did write this all in your assignment, but I also want to clarify this to make sure everyone's on the same page with these things. After that, I'll take some questions. I already have assignment 4, question 3 on the docs that someone asked me to go over, so I'll go over that for sure. Take this time now to post in the chat to see, to let me know what kind of problems that you want to go over. So whichever ones, assignment 4, assignment 5, from the handout, whatever you are experiencing difficulty with, let me know. I'll go over as many of those as I can, time permitting. If not, we'll move on to the new material. So take a minute now while I get the lecture prepped and ready to post in the chat. Let me know what questions you want to go over. Okay. So far I have factoring package 3B. I have number assignment 4 and number 3 on the docs, assignment 5, number 2, probably number 1. Anything else? Question 4. And I'll talk a little bit about question 3. Yes, I know we have some notes from assignment class 5 that we didn't finish. We're going to go over them today. Okay, so we'll get started and then pop in anytime there's a question or issue or anything like that. So before we get started on the questions, there are a couple of clarifications that I'd like to go over that I noticed. They're basically common mistakes that I saw. So the first one is from assignment number 4. You had this question where you ended up with, ridiculous, x squared plus 4. So this came from x to the 4 minus 16 being factored into x squared plus 4 and x squared minus 4. Now I'd like to clarify that this is not a difference of squares and this is a difference of squares. So a reminder of what difference means. Difference means subtract. This is a subtraction. This is an addition. So this is not a difference of squares. So I saw some people saying, well, this is a difference of squares, and factored it like this. This is not okay. You can do that with this one. But not this one. This is not a difference of squares because it's not a difference, it's a sum of squares. And there is nothing you can do. If you try to factor this, you go through your tools. There's no GCF. You can't factor by grouping. It's not a trinomial. So the only thing you're left with, is it a difference of squares? Which it's not. So this is factored. So there's nothing you can do here. That brings me to my next point about this specifically, is that x squared plus 4, when you're solving for a restriction for that, this moves over. So I saw a lot of people get to this step and then decide that this can be square rooted. But you cannot square root a negative. So actually, when you get to this point, so you can't do this. When you get to this point, what this means is because you cannot square root a negative, there's no restriction coming from this. And you're done. So be careful when you get terms like this. For instance, even x to the 4 plus 16 would not factor, because as soon as you have the plus here, you're roadblocked. So that's just a quick clarification on that front. Clarification number 2 would be this one. So this came from problem assignment 4, number 3. So before we actually do this problem, I just want to clarify what this is, okay? So some people said, well, this is x squared plus 9. That is not the case. You cannot just distribute this in like that. This is a perfect square trinomial, which means that I have x squared plus 3 times x, which is 3x times 2, which is 6x, plus 9. You have to have this middle term for a perfect square trinomial. The only time this 2 gets distributed in is if you have a product in here. If this is a product, then you can do this and say this is a squared b squared. Or if you have 3x, you get 9x squared because this distributes to the 3 and to the x. But when you have a binomial squared, you have to have your middle term. Square of the first, 2x times 7 is 14x times 2 is 28. 7 squared is 49. So you have to have that middle term. That brings me to assignment 4, number 3. So assignment 4, number 3, you had this. So to expand this, you expand it using the perfect square trinomial relationship. And then you've got this part. You put your like terms together, and that gives you x squared plus x minus 6. Product is 6, sum is 1. So this breaks into 1, 6, 2, and 3, with the smaller number being negative. So I have x squared plus 3x minus 2x minus 6. Regrouping, I can pull out an x out of the first 2. Out of the second 2, I can pull out a negative 2. And you regroup to get x plus 3, x minus 2. How did I get 6x? Because you take the first term times the second term. So x times 3 is 3x times 2. So you go x times 3 times 2 gives you 6x, and that becomes your middle term. Emily, you asked me for the factoring package 3. Cancel. What is happening? 3B. Would that be this one right here? Yes. Okay, perfect. 5x squared minus 2x minus 3. Ooh, not yellow. Just to go back to the previous question before we start this, I was asked when both are positive, one side is negative. Talking about here, this product is -6. That's why when we have a negative here, one of our columns has to be negative. Because this is positive, the smaller column becomes negative. All right, so here I have a product of -15 and a sum of -2. So here I have 1 and 15, 3 and 5. -2 means I have negative. That gives me this one. So 5x squared minus 5x plus 3x minus 3. Here I can pull out a 5, x minus 3. And here I can pull out a 3, that's an x. Oh my goodness, just don't even listen to me when we do this. Here I pull out a 5x, and I'm left with x minus 1. And here I can pull out a 3, and I'm left with x minus 1. And regrouping, this gives me x minus 1 and 5x plus 3. Okay. All right, we'll go to assignment 5. Number 1 was tricky, so we'll take a look at it. So this is assignment 5. So we have 3x plus 12 divided by 5x squared plus 2x divided by 2x to the 4 plus 6x cubed plus 4x squared divided by So this is a huge rational expression. Hopefully you won't get something this complicated on the final, but you never know. So essentially all you're doing here is you're going to factor everything. So here I can pull out a 3, x plus 4, and I can pull out here an x, 5x plus 2. I'm going to change this to a multiplication, which means that I'm flipping these. Now this one is the most difficult part of this. So here I get 5x plus 4 squared minus 4. That's a difference of squares. So I get the square root of the first, square root of the second, one is plus and one is minus. Here I can pull out a 2x squared, and that leaves me with x squared plus 3x plus 2. And this last term, here I can pull out a 6x squared, leaving me with x plus 1. And here I can pull out a 9, which leaves me with x plus 4. I'm just going to rework these. So here, putting this together, we have the 5x, 4 plus 2 is 6. Same thing here, we have the 5x, 4 minus 2 is 2. And then here, you would factor this trinomial. I'm just going to do it a little bit quicker. Now you're playing a canceling game. So essentially, you're looking for common factors. So here I have an x plus 4. Here I have an x plus 1. Here I have a 5x plus 2. Here I have an x squared and an x squared. Here I have a 3 that will become a 1 with this 9 that becomes a 3. This 2 will become a 1 with this 6 that becomes a 3. And the 3's go away. What am I left with on the top? 5x plus 6. And I'm left with x plus 2. The last comment, you missed it because you missed it when you were doing it, or you missed it when I was explaining it? Because if it was when I was, okay, perfect. Just wanted to make sure it wasn't something you missed when I was explaining it. All right, so this one was a major problem. Hopefully you won't get something this extensive. Can I go over it? Yeah. So here, basically what you're doing is you have to, if you never got the attachment for assignment 5, you have to send me an email. There's an issue because that assignment 5 went out to everybody. Okay, so basically when you have a problem like this, you always factor. So here to factor, I pulled out a 3, leaving me with x plus 4. Here I pulled out an x, leaving me with 5x plus 2. Same thing here, I factored this, 6x squared got pulled out, leaving me with x plus 1. The 9 got pulled out, leaving me with x plus 4. Now because this is a division, we know that divisions turn into multiplications if we flip this fraction. So I flipped it. This was the tricky part. This is a difference of squares. So I have something squared minus something squared. So that factors into the square root of the first thing, which is just, when I square root this, the 2 just goes away and I'm left with 5x plus 4. Square root of the second is 2. So you have a plus and a minus. It doesn't have to be in the same bracket because you have something squared minus something squared. That's a difference of squares. Because theoretically, when you have this, what you're saying is I have x2 squared minus 2 squared. It's a difference of squares. And since this is the complete bottom, I can play that game. This, a 2x squared gets pulled out, leaving me with x squared plus 3x plus 2. And then I put a whole bunch of stuff together. So this I just recopied, this I just recopied. And then here, 5x plus 4 plus 2 gives me 5x plus 6. I know, that's like, this is like worst case scenario of difference of squares. So let me just finish going over that problem and I'll give you another example like that. 5x plus 4 minus 2 gives me 5x plus 2. And then this trinomial factors here, x plus 2, x plus 1. Then it's just a canceling game with whatever you see. And that leaves you with this as your solution. Yep. So anything that's on the top can be canceled with anything that's on a bottom, anywhere in the whole expression. So that's why you can do the x plus 1 here and the x plus 1 here, the x plus 4 here and the x plus 4 here. As soon as you have pure multiplication, you just start canceling whatever you want. A difference of squares, remember, is something squared minus something squared. Okay? I'm just going to go over this quickly and then we'll go over some more of assignment 5. So just so we are clear, it doesn't matter how these somethings are presented. In this case, I have this thing squared and this thing squared. So it's no different. My brackets become the square root of the first, and the square root of this means I just take this away. Minus and plus the square root of the second. Again, that means that this just goes away. The way you handle it is no different. Then here you put this together. So I have x minus 2x. That gives me negative x. 5 minus 3 gives me 2. X plus 2x gives me 3x. 5 plus 3 gives me 8. Okay, so the way you do difference of squares doesn't change. It's difference of squares. So it's something squared minus something squared. Factors into the square root of the first, square root of the second, 1 plus 1 minus, that's it. All right, we'll go to assignment 5. Number 2. Remember that I will be giving you feedback on this today. Okay. So here what you need to do is you need to factor. So if I'm doing this quickly, I just have to remember. Move this over. I will get it. So just quickly, you product sum it, you get the factors. Now here you say, okay, I have an x plus 7 and I have an x plus 7. I'm good to go. Here I have a 5x minus 3. This doesn't have a 5x minus 3, so I need to put it. And this one's taken care of. Here I have a 2x plus 3. That's missing on this side, so I do the same thing. I put these together, so I get 2x plus 3, x minus plus 1, plus 4x plus 1 multiplying 5x minus 3 all over my huge new denominator, which is 2x plus 3, 5x minus 3, and x plus 7. So just for the purposes of this assignment, this would be enough for your answer, okay? Yeah, so this would be your answer. You could theoretically multiply these in and then try to reduce it, but I was just looking to see for this assignment if you knew how to find the common denominator and take care of that issue. Okay. You mean you were stuck at this step? Well, in theory, the next step would be, if you're doing this whole thing, is you would FOIL all of these if you wanted to. I'm just moving through this quickly. Over. And then you would put your like terms together, giving me 22x squared plus 10 minus 12 is 2. 3 minus 12 is 9. So you could do that. But like I said, I was just really testing to see how you did with the common denominator. On the bottom, there's only one of each of those factors, because what I did is I've created this. If you notice, this is the exact same of this as this. That's my common denominator. So it's just like with fractions. Once you have the common denominator, you add the top, but you just recopy the bottom. Okay, there are some questions about volume. We're going to take a look at that one right now. We're not actually going to do it because I just want to give you an idea of the steps to follow. Number 3, it says the base of the following prism is a right triangle. What is the expression that represents the volume of the prism? So a volume of a prism is area of the base times height. We'll make it a big H. It's a triangular base prism. So how do you find the area of a triangle? Well, it's 1/2 base times height plus the big height of the prism. In the problem, you're given the small base, the base of the triangle, which is 3x plus 6 over x squared minus 2x plus 1. You're given the height of the triangle, which is x squared minus 1x plus 2. And then you're given the height of the prism, which is 2x minus 2 over x plus 1. So basically, you just plug those 3 expressions in and then do exactly what we just did. Factor, cancel out, final answer. So I'll let you try that one. Number 4. Number 4 leads us into what we are talking about today. So on Friday, we left off with solving quadratic equations. So basically, you're setting one side to 0 and factoring to find your possible solutions. But we didn't do any word problems. We're going to do a couple of those today. Basically, the added bonus with word problems is you just have to create your equation and then plug it in and solve. You also have this added bonus that we'll look at the end. Okay, so in this case, it says the area of the hexagon is 1/2 S times A times N. We remember that this is the side measure, the apothem, and the number of sides. We're told that the area is 108. So I have the side measure, which is 4x minus 3. I have the apothem, which is 2x minus 2. And I have the number of sides. It's a hexagon. There are 6. You could also just count them. So in order to solve this, I need to move everything to one side, but I'm going to have to expand this first. So this 6 and the 2 cancel to give me a 3. So I'm just going to put the 3 there. This expands. I get 8x squared minus 8x plus, nope, not a plus, minus 6x plus 6. I'm going to divide both of these sides by 3 because I can, and I want to make this the simplest equation possible. Gives me 36. And then I get x squared, 8x squared minus 14x plus 6. And I move this to the other side, giving me 0 equals 8x squared minus 14x minus 30. So now essentially you're factoring it to be able to solve. First thing I'm going to do is I'm going to take out the GCF of 2 because that makes my life a lot easier. Get rid of the 2. Now, essentially, you would be product summing this. Yeah. Not good. So I'm going to do that very quickly just because we're running out of time to go over these problems. Product summing this gives you 4x squared minus 12x plus 5 minus 15. And we work this through. Now, with these ones, you now set each of them equal to 0 to solve for your possibilities. So I move the 5 over, and I get 4x equals negative 5. Dividing by 4 gives me negative 5 over 4. X equals 3 on this side. So I have 2 possible solutions. Now the added thing that you have to do with word problems is you have to see what if your answers make sense or not. Okay, Leo, I'm going to answer your question in just 1 second. Just let me finish up this problem. So you have to go back to your problem. So just like with some problems, like if you're doing real life situations, it doesn't make sense to get certain answers. For instance, if you end up with 0.5 of a person, 0.7 of a battery, a negative length, none of these things mathematically make sense. So you take each of these answers and you go back to your original question because they're legitimate in terms of the math, but they may not be legitimate in terms of the problem. So in this case, your side measure is 4x minus 3, and your apothem is 2x minus 2. So if I plug this in, this gives me negative 4.5. Does it make sense to have a negative side measure? Nope. Which means that this is not a legitimate possibility. So my only solution is x equals 3. So we're going to do 1 or 2 more word problems because it's basically like the same thing, except that you have to have that added step that says check your answers to see if they make sense in terms of the context of your problem. Leo, just to answer your question, so the question is if you use trial and error to find the x value. Trial and error to find the x value, you don't lose points for trial and error in theory. But in theory, If this isn't some sort of perfect number, it's going to be extremely hard to find it. Like trial and error, you probably wouldn't have stumbled on x equals -5/4. Now, if you don't find this possibility and reject it, you will lose marks because you haven't actually completed the problem to its fullest extent. Because to complete this problem, you have to find all the solutions, but then acknowledge that one of the solutions doesn't make sense. So you may have got an x equals 3, and then you found the perimeter and it's correct, but because you missed like the side stream of it, you would lose marks for that part. But if you're stuck, absolutely use trial and error, because you would lose less marks getting through to the end and using trial and error and just losing a couple marks for this part than you would if you stopped here and said, I have no idea what to do. So it's a backup. Okay, cool. So just one more side note, something I wanted to take a look at with you. Restrictions. You have to find the restrictions before you cancel out. So in theory, my answer is x plus 3 over x plus 2, but my restrictions still would be x cannot be 5 and cannot be -2, because those restrictions existed in my original equation, so it's still a restriction. So that's why you do restrictions before you cancel. So in theory, in this problem, this one, if you were asked to find the restrictions, this would be a huge pain, but you would have to find the restrictions from anything that was or is a denominator before you factor. So it's not like you have only x is 0 and x is -2 as restrictions. You would have -2/5, 0. You would have -2, you'd have -1, you'd have -4, you'd have -6/5. So you would have all these different restrictions that existed in the original equation, so they have to be acknowledged before you can move on. Okay? Awesome. Question 3 from the quiz. Then we really have to move on. Question 3 from the quiz is this one. So I move everything to one side. Equals 0. My product is 90. My sum is 47. So you could go all the way through, but you're going to end up using 2 and 45. Regrouping here, you can take out a 2x. 2x, leaving me with 9x plus 1. And here, you would take out a 5, leaving you with 9x plus 1. Regrouping gives you this. Solving each of these individually. Whoops. Setting them each equal to 0 and solving gives you two possibilities. So these would be your two solutions. So your answer is A. All right, so we are ready to do a couple of more problems involving word problems. So now we're on the first page of the notes. Oh no, we're doing this first. Okay, this is a test problem. So this is a problem like you could expect to handle in the final. So this kind of problem, it says that you have this pattern that you're following. And they're testing. So you have all these numbers that when you do step one, and then you do all these different steps, you get the number back that you started with. So it says, prove that this works for any number. If you're proving this works for any number, you're not just going to test every number in the world. You're going to do this with a variable and see if it pans out. So you start off with x, meaning my step one is x. Step two. So basically we're going through all these steps with x and seeing if we get back what we started with. Step two, multiply the chosen number by 10. Step three, add 9 to this product. So we have 10x plus 9. Step four says add the square of the number in step one. So the square of step one, add this to your step three. Step five says, we'll actually do step 5 over here. I have more room. Step 5 says, divide the result in step 4 by the sum of 9 and the number chosen in step 1. So this is a long division. So I'll just go through this quickly, hoping that we remember what we do for long division. Dividing gives me x, multiplying each term, this cancels out. 10 minus 9 is x, bring down the 9, that gives me a 1, multiplying again, and subtracting. X minus x goes away, 9 minus 9 gives me 0. Step 6 says subtract 1 from the quotient. So your quotient is your answer, and I'm going to subtract 1, and that gives me x. This means that no matter what I do, no matter what number I choose, this relationship will always be true. So I could choose 10 as my x, and I'll get back 10. I could choose 1,000 as my x, I'll get back 1,000. I could choose negative 25, and negative 25 will work out. So this is an example of a 10-point question that involves algebra. So basically, you would just organize yourself, go through the steps with the algebra, and then you would say like, oh, therefore, no matter what number I choose, I'm good to go, okay? If you chose a number and just did it with a number, you're probably getting like 2, maybe 3 on 10. So when it says, prove that this trick works for any number, make sure you're using any number, which means you have to be using a variable. Okay? Alrighty then. Word problems. So we're going to do a couple of more word problems. So basically these are problems like number 4 in the assignment. So we're just going to take a look at these. If you remember, question 4 in the assignment, we were solving quadratic equations, but we were doing it with the added bonus of whatever answers that we got, we had to go back and see if those answers made sense in terms of our problem. So we'll do number 2. A triangle has an area of 27 meters squared. Its width, we'll call this base, is represented by x, and its height is represented by x minus 3. Solve for the value of x. I didn't even really read. It says triangle area. I write down my formula. I'm going to write it down this way because it's actually a little easier for me to do. Base times height divided by 2. I know that the area is 27. I know that the base is x, and I know that the height is x minus 3, and I still have this divided by 2 here. So now you're going to manipulate this equation so you get something you can factor, on one side being 0. So if I bring this up, I get 54, and I bring this in, x squared minus 3x. To solve this, I need to bring this over, or I can't factor. You're going to product sum it. I'm going to jump those steps just because we're running low on time, and at this point the expectation is that you know how to product sum. So we would get 9 and 6. Regrouping, we would get x and plus 6. Jumping to x plus 6, x minus 9. So like I said, when you get to this point, you have to set each of the individual factors equal to 0. So in this case, you would get x is negative 6, and in this case, you would get x is 9. Now, in the problem, it said that the base of the triangle is x. What does base of negative 6 mean? It means nothing. It's nonsense. So I have to reject this answer. So my base is 9. My x value is 9. So because the negative 6 doesn't make sense in context of my question, I reject the answer. So if you don't have a word problem, both of these answers are completely legitimate. If you have a word problem, you have to analyze your answers based on the context of your question. Okay? Cool. All right. I'm going to do number 3. All right. The product of the first, this one's a little wordy, so you have to take it a bit slow and really step through the wordiness of it. So we have first and third integers of 3 integers. So I'm going to say integer 1, int 2, and int 3. So consecutive, positive, odd. So if I have 3, it would be, the next odd number would be 5 and 7. If I have 12, you can't, it's odd. If I have 15, it would be 15, 17, 19. So that's how we consecutive odd number it. So if I call this x, how do I get to the next one? I'm going to add 2, right? Because that's how we get from 5 to 7. We add 2. Then I'm going to take the next one, go from here to here, I add 2, meaning I have x plus 4. So those are my integers, x, x plus 2, and x plus 4. Now it says the product of the first and third integer is 7 more than 10 times the middle integer. So to make these equal, I have 10 times the middle integer. This one's more, so to equal it out, I add 7 here. Or you could subtract 7 on this side, it really doesn't matter. I manipulate this equation, so I bring the x in. And now I need to put everything onto one side. Four minus 10 gives me negative 6. This is 27 over here, so it's going to be negative 27 on this side. I changed it to +7. It says exceeds, but why is there an equal sign? Because it says it's basically exceeds, meaning it is 7 more. So in order for them to be the same, I would just have to balance it out by putting a 7 here. Pen's upside down. Putting a 7 here or putting a -7 here. So you want an equation with an equal sign. Otherwise, this all goes away and there's nothing you can do. So you want to create an equation with an equals. In order to make them equal, they're saying that this is 7 more than this. So to balance it out, I add the 7, and now these two things are equal. Once we get here, I'm going to skip this step. Product sum. So again, I have the two different equations. So I have x minus 9 equals 0, which gives me x is 9. And x plus 3 equals 0, so x is -3. Lots and lots and lots of practice. So the question is, how do I product sum so fast? Lots of practice. You would actually do the work. So I'm just trying to get through the problem, because in the problem, our focus here is more the answers than it is about the product summing. Why was it x plus 2 for the integers? Because if you're saying consecutive integers, it means consecutive meaning in a row. But consecutive odd, meaning I want 3 odd numbers. So if I have 5, the next odd number is 7. How do I get from 5 to 7? I add 2. The next odd number would be 9. How do I get from 7 to 9? I add 2. So if I have x as my first one, I add 2 to get to this one. And then how do I get from this one to this one? Well, I take that and I add 2 to it, which gives me x plus 4. Now I have to look at my answers in the context of the question. So, yep, both of these are integers. Yep, both of these are negative. But it says the product of the first and third integers of 3 consecutive positive odd integers. So this says positive. -3 is not positive, meaning my x is 9. So this is 9. This is 11, and this is 13. We'll just set up one more. Or not going to do this one. That's it's a little bit too hard. Can you go over the first step with the 10 and 7 again? I'm a bit lost. Sure. So no problem. This one's really wordy and really tricky. But basically it says, there's writing everywhere. I'm just going to get rid of this. So you take it one step at a time. It says the product of the first and third integers. So I take the product of the first and third integer. It's saying it exceeds this by 7. So it is more than 10 times the middle integer. So I have 10 times the middle integer. And this is 7 more than this. So in order to make them equal, if this one's 7 more, then I can just add 7 to this side, and then they're balanced. But you cannot write this because they're not equal. It's saying that this is 7 more than this. So to make them equal, I could do this. Now they're equal because if I increase this by 7, it's going to be the same. The other option would have been to say, if this one exceeds it by 7, if I take it down by 7, that'll give me the same thing. Now they'll be equal, the two sides. Either one of these would have been okay, and you still would have gotten to this step, and it would have been identical. So like I said, this one's a bit wordy and funky, but other than that, we just have to take it step by step and really try to understand what they're asking of you. Okay? You're welcome. All right, so what we are going to be doing today, analytic geometry. Now, if you notice, there are 30 pages approximately. We are not going over all 30 pages. There are a couple of elements that are new in analytic geometry, or some might be new, some you might have seen during class. But I included all the notes on analytic geometry just to give you a little bit of a refresh about the types of problems and the types of tools you have for analytic geometry. So the pages that you've already, of things that you have already seen in CST, there's nothing missing. I didn't take anything out. So we're just going to take a quick look, acknowledge its existence, and then move on. For example, as a tool, half planes we're going to cover. So there are, like, it's the stuff that's new is in the middle of the notes. So it's like middle, towards the end, and the end. So half planes, some of you may have covered this, like I said, but it's not, you didn't necessarily cover it. It depended on your teacher. So I'm just going to make sure that because some people may not have, that we all cover it together. So there are a couple of different things that, depending on who you had as a teacher or whatever it is, you may have seen this already, but some people may not have. So bear with me if you have. So we start off with distance between 2 points. So you have this formula, distance between 2 points, put it on your memory aid. Midpoint. Given 2 points, you can find the exact middle of the 2 points. You have these two formulas, put them on your memory aid. So for each of these different things, I've also provided some examples. So if you want to practice with the midpoint or practice with distance, feel free. Division point. So division point, you have a line that's connected, or a segment connecting 2 points, and you want to find a certain point along that segment based on a given ratio. So that's what division point does for you. Depending on how it's presented, either you're presented with the fraction or you're presented with the ratio. The ratio is the ratio by which that division point divides the line. And then you have the actual formulas for division point. So there are a couple of examples here. Find the division point, find the starting point, find the ratio. This is where we're going to start with theoretically review / new. So you do need to copy these ones down. The blue part is missing. I know it's not new, and I know you've probably seen this in depth in Sec 3, but it's important for a lot of analytic geometry stuff. So we're just going to take a quick look at it. You also have this formula down here, so don't forget about that. Okay. So here we have the different types of slopes. So positive slope is a positive A value. You have an upwards inclination. So that is the red line. So as you move from left to right, your values are increasing. Negative slope means that as I move from left to right, my values are decreasing. So we have the blue line for a negative slope. A zero slope is a horizontal line. The rule is y equals b. Wherever it crosses the y-axis, that's the number for our equation. And as it's the horizontal line, it's the green. And then finally, we have an undefined slope, meaning we have a vertical line. X is c. So it's the value where the line crosses the x-axis. Vertical line, undefined slope, that's the orangish yellow line here. Down here, we have the formula for calculating slope. Like I said, you do this over and over in Sec 3, so we're not going to do these examples. Hopefully we know how to apply that rule properly, but there are some there just to do a refresher if you're not sure. And feel free to email me if you're not sure. So just quickly, you'll have all of this stuff. Nothing's missing here. The intercepts are the values where the function crosses the x and y axis. They have the form. The x-intercept has x and 0. So for example, you could have 2 and 0. That means that this function crosses the x-axis at 2. Or you could have the y-intercept presented as 0 and 1. Or 0 and b. So for instance, 0 and 10, that means that the line crosses the y-intercept, the y-axis at 10. Putting all of this together, we had the functional form of lines, standard form. Y equals ax plus b, something hopefully you'll never forget. So you did this again in secondary 3, lots and lots of stuff. So you have y equals ax plus b, where a is the slope, which you find using this formula here, y2 minus y1 over x2 minus x1. And you have b is the y-intercept. So to find the rule, given 2 points, you calculate the slope using the y2 minus y1 over x2 minus x1. You plug in a point and slope to solve for b, and then you have your rule. So these examples, you're given 2 points, and you need to calculate the rule in y equals ax plus b. So you just follow these steps. Graphing, we're not really going to talk about. Here's where we get to the material where some of you have covered it and some of you have not covered it formally. You've all seen it in a really non-formal way when you did systems of equations, but some of you may not have seen this in class as like its own entity, its own thing. So we're going to start this as theoretically new material. So if you have seen it before, just bear with us. If you haven't seen it before, let me know. And if there are a couple of people that haven't, we'll do it a little bit slower. If everyone has, then we'll go through this relatively quickly. So basically what this is we have different forms of lines And we're going to talk about two new forms of lines. So general form is the first of that. So I'll let you copy this down and then we'll talk about it. Are we ready or we need another minute? Okay. We'll get to that. I'll definitely answer that question when we get down. Okay, so general form of a line. So ax plus by plus c equals 0. So for example, we could have 2x plus 3y minus 12 equals 0. That is a general form of a line. So what do we need to have general form of a line? The a, the b, and the c have to be non-zero whole numbers. The whole number part of this is the most important part of it. Okay, so we can't have any fractions or decimals. The a term has to be positive, so the number attached to the x has to be positive, and one side of the equation has to be equal to 0. So we're just going to take a look at this here. So if I have 2x minus 3y plus 3y, it really doesn't matter. Minus 12 equals to 0. It's just a line. In the Cartesian plane, just a line. But this note says a line can have many different general forms. So it can have only one functional form, where in this case, we have negative 2 over 3x plus 4. So that would be this rule in functional form. But I could take this here and put another general form. And I still have the same line. But notice that I took all of these numbers and I multiplied them by 2. I could multiply them by 10. It's the same line. So as long as I'm multiplying all of the different terms by the same number, I'm getting the same line. So I could do this forever by choosing any number I want, as long as one side stays 0 and the a term stays positive. The other formula that this is super important, slope is negative a over b. So if you notice here, the a term is 2, the b term is 3. Negative a over b means negative 2 over 3. See, it's negative 2 over 3 here. So we're going to work with that a little bit. The benefits of using this is that A, B, and C are are whole numbers, so we don't have to deal with decimals and fractions, and I know how much we love dealing with decimals and fractions, so that's a benefit for us. And it's really, really easy to solve for the intercepts in this form. Not really, really easy, but it's easier to solve for the intercepts in this form. So just like this is just like a basic definition. So an oblique line means it's not vertical or horizontal. So as long as A is there and B is there, I'm going to get an oblique line. So this is an oblique line. 5x minus 3y plus 7 equals 0. That's an oblique line. 12x plus 17y minus 50 equals 50, whatever. Same thing. This is an oblique line. But if I take out either A, so if A is gone and I just have B, this should be minus 50 equals 0. If I take A out and I just have B, 18x minus 6 equals 0. Sorry, 18y. If I just have B, then here I have a horizontal line. And if I only have the A term, 5x minus 15 equals 0, then I have a vertical line. So that just means that this is general form, this is general form, and these are all general form. You just have 3 different cases. But most of the time, you're going to be working with this one anyway, so don't worry about it. To calculate the intercepts, you're going to set either x as 0 or y as 0 and solve, and we'll see why this is actually easier in general form than anything else. We're also going to convert, so I'll give you a minute to write this down, and then we're going to do examples of converting and solving for the intercepts. They're just writing. Which pages did I miss from Friday's lecture that we didn't cover? They have page numbers at the bottom. Which page numbers were they? Oh yeah, we're going to do that tomorrow. That's going to be done tomorrow. That's fine. I was going to do it on Friday, and then I decided it would go better with tomorrow's material. So, is that the only thing, though? As far as I know, that's the only thing. Okay, perfect. So we're gonna cover that tomorrow. No worries. All right. So converting to functional form. Basically, when I'm converting forms, all you want to do is basically you're following the criteria for having that form. So for functional form, I need slope and y-intercept, so I need to get that stuff. For general form, I need whole numbers, one side 0, and a being positive. So let's take a look at what that looks like. Cool. So here I'm going to convert the following lines to general form. So I need 3 criteria for being in general form. 1, I need all whole numbers, and you follow them in this order because otherwise you're going to end up doing more steps for nothing. Whole numbers, I have all whole numbers. Now I look at my A term. Right now it's positive, meaning I don't want to touch it. I want it to stay where it is, but I need one side to be 0. So I'm going to move this over here, and I get 0 equals 2x minus y plus 3. This is a general form. For the second one, I'm just going to throw a little negative in there. Negative 2 over 3x plus 5. So the first thing I want to do is take care of this denominator because I can't have it. So what I do is I multiply the entire equation by whatever that denominator is. In this case, it's 3. So 3 multiplies y gives me 3y. Negative 2 times 3 is negative 6. Divided by 3 is just negative 2. Or you could just look at it as they cancel out. And then 5 times 3 is 15. Now you're going to do 2 steps in one. You want A to be positive and one side to be 0. Right now A is negative, so this is going to flip to this side, giving me 2x plus 3y minus 15 equals 0. So if you just jump down to number 5, we can do the same thing here. Why did it become a negative 2? It was, I changed the question here because I wanted to do it with a negative. If you jump down to number 5, it's the same situation. So the first thing that you're doing is you're getting rid of the denominator. So you're multiplying the whole equation by whatever this number is. It's 6. So 6 multiplies y. 6 cancels with this 6, and it just leaves me with negative 5x. And this 3 multiplies with this 6 to give me 18. Again, you want one side to be 0, but you also want your A to be positive. So you're looking right now, as of right now, A is negative. So what this means is you want this stuff to go to this side, both of it. So you end up with 5x plus 6y minus 18 equals 0, and this is general form. We're going to do number 2. So in this case, you're given general form, and you need to find the y-intercept, the x-intercept, and the slope. So like I said, this is actually a little bit more straightforward than it is with something else. So when I have the x-intercept, or y-intercept, sorry, that means that x is 0. So I'm going to solve. This is A. 3x plus 4y plus 8 equals 0. If x is 0, this term disappears because 3 times 0 is 0. So I can essentially just erase this whole thing here and solve this equation. This is what we call the hide and seek method. So essentially we're hiding this term here or this term here, depending on which intercept we're solving for. So this moves over as a negative 8. And we divide by 4, and we get y is negative 2. So 0, negative 2, that's my y-intercept, or that's a point on my line. B is the same thing. So for the y-intercept, this means y is 0. So I have 3x plus 4y plus 8 equals 0. So if y is 0, this term disappears, meaning that I could just erase it. And now I'm solving this equation. So this moves over, and I divide by 3, giving me x is negative 8 over 3, which is a point on my line. C, the slope. Here, you are given a slope formula, negative a over b. So I have negative a over b. This is negative 3 over 4 because we have 3 as my a and 4 as my b, and I'm done. That's the slope. That's simple. Now, if I wanted to write this in functional form, just as like a side note, I have y equals ax plus b. Well, I just solved for my slope, which is negative 3 over 4. I solved for my y-intercept, which is negative 2. That's functional form. So if you look, if we graph it, wrong thing. If I graph this, y equals negative 3 over 4x minus 2, or 3x plus 4y minus 8 equals 0. Whoops. Plus 8 equals 0. I have the same line. So I just converted it so the forms are different, but I'm not actually graphing anything different. Same thing here. If I want to convert to functional form, step 1, slope, negative a over b is negative 11 over 2. 2, y-intercept. I do the hide and seek method. So I have 11x plus 2y minus 6 equals 0. So if I'm hiding the x term because I'm solving for y, essentially I'm just erasing and saying 2y equals 6, dividing by 2 gives me y equals 3. So this equation in functional form is y equals negative 11 over 2x plus 3. You also can just isolate y with algebra if you want to. This is just a more straightforward. Here, if you want to isolate y with algebra, you can. So you would just move this over. And then you would divide everything by 3. It gives you 2 over 3x minus 1 over 3. That's fine too. It's up to you. Some people find it more straightforward to do it this way. Some people find it more straightforward to do it this way. I don't care. Whatever you want. All right, so that's general form. We have a new form. So this, in theory, should be new for everybody. So copy this down and then we'll talk about it. Let me know if you're not done. Cool. This should be a new form. Maybe some of you have seen it. That's still okay. So this is for lines that don't pass through 0, 0. So we have x over a. I'm just going to put these to 2 dots because we don't want this to be confused with a negative. So x over a plus y over b equals 1. A is the x-intercept. B is the y-intercept. And we have one side of the equation that's equal to 1. We also have this little slope formula that will be very helpful for us as well. So a and b can be positive or negative. And it's easy to graph in this form. You're usually not asked to graph, but in theory, you just graph those 2 points and sketch the line between them. You may have to convert. So again, with conversions, all you're doing is paying attention to the criteria for each of the different forms. So for functional form, you need slope and y-intercept. For this form, you need the x-intercept on the bottom of the x, the y-intercept on the bottom of the y, and one side equal to 1. For general form, you need no denominators, one side equal to 0, and positive a. So from symmetric to general, you just have to follow the criteria of general, get rid of the denominators, one side equal to 0, a positive. From symmetric to functional, very straightforward, all you do is calculate the slope. To symmetric, from either, you calculate the intercepts. That's it. So let's take a look at this. All right, number 1, given the following rule in symmetric form, find the slope. So in this case, the slope, you had the formula, it's negative b over a. So in this case, my b is 12, and my a is negative 4. So the negatives cancel, and I get 12 divided by 4 is 3. The x-intercept is x equals negative 4. That's it. The y-intercept is y equals 12. That's it. Convert to standard or functional. Well, we just did it. This is the slope. This is the y-intercept. So y equals 3x plus 12. If I wanted to convert this to general form, just need a little bit of room here. Or no room, that's fine. All right, if I wanted to convert this to general form, what is happening? Okay, cool, it's just doing whatever it wants. All right. We'll do an example of this down here. Dun, 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 dun. Okay, convert the following to symmetric form. Symmetric form, I just need the intercepts. So here I would just solve for the intercepts. So we need the x-intercept. So again, we're doing the hiding. So if the x-intercept where this disappears, I get 2x minus 6 equals 0. Moving this over, I get 2x equals 6. So x is 3. I need the y-intercept. And with the y-intercept, it's opposite. So instead of removing this one, we remove this one. So we get 3y minus 6 equals 0. 3y equals 6, dividing by 3 gives us y is 2. So my symmetric form is x over 3 plus y over 2 equals 1. Same thing here. I have the y-intercept, and it's 10. To do the x-intercept, I set y as 0, and I'm going to solve. So 0 equals negative 4x plus 10. If I bring this over, 4x equals 10. Dividing by 4 gives me x is 5 over 2. So I get x over 5 over 2 plus y over 10 equals 1, and I'm done. We'll do one example from number 3. I don't care which. We'll maybe do this one. We'll do A. So if I'm converting the following into general form, once again, I have to follow the 3 criteria. No denominators. So that's what I'm going to take care of first. So what I want to do is I want to multiply this equation by something that will cancel out both of those denominators. So I'm going to choose 15. So 15 times 1 divided by 3 gives me 5. 15 divided by 15 gives me 1. And 15 times 1 gives me 15. The x is positive, the a term is positive, so I don't want to touch it. I'll move this to the other side. So I have 5x plus y minus 15 equals 0. And that's how I convert to general form. Multiply, check the a term, one side 0. So now when you're handling anything analytic geometry, you're still handling the same type of problems, but things could be given to you in symmetric form. It could be given to you in general form. You could get the parallel perpendicular question, like find the rule of the line that is parallel to this line and passes through this. You could get that with the original line being in symmetric or general. So you should be able to handle both of those things just using the slope rules. Can I explain what I just did, and can I do B? Yes. So I'm going to do B, and hopefully that'll clarify A. So you want to go to general form. You want to get rid of these denominators. So I'm going to pick a number that will cancel both of them out. So I'm going to pick this one, 10. So this 10 distributes to every term. So 10 times 1 divided by 10 is just 1. 10 times 1 divided by 2 is 5. And 10 times 1 is 10. Because this is positive, I'm going to move this over, and I get x plus 5y minus 10 equals 0. So that's it for symmetric form. On your handout today, there are a lot of questions involving symmetric form, so just make sure you pay attention to those. We have one last tool that we're going to talk about. So just before we move on, when you're finding the rule of the line, you're going to find the rule in whatever form you can. If you're given the slope and B, or A, the slope, if you're given the slope and the B, if you're given A and a point, or if you're given 2 points, all of these you're going to use this form. If you're given the intercepts, you're going to use this form. It's not wrong to use the other ones, but it makes it a lot easier depending on what information you're given. One last tool. So parallel, perpendicular, these are all things that you should be able to handle now with these type of questions that come up a lot in part A. Perpendicular, same deal, special cases. This is the new material. So this is the last tool that we're going to use. So this adds on to distance and midpoint and division point. Can I go back to where? Because we have to move on. We really don't have much time left. Where can I go back to quickly? What page? Good. Whoops. Okay. Distance point to line. So you have a distance between 2 points, but sometimes you want the distance between a point and a line. Now, in the Cartesian plane, you have this line, let's say, and we have a point. What I want this is all there is, guys. Essentially, what I'm doing is I'm finding the shortest distance between this point and this line. Because I'm sitting at a desk in the classroom. If I want to get to the door, I'm not going to zigzag around every single desk in this classroom to get to the door. If I want to find out what the distance is between me and the door, I'm going to take the shortest route. So what this means is the shortest route is the line that connects the point to this line and meets it at 90 degrees. Because theoretically, I could connect it here and find that distance, or here and find that distance, or here and find that distance, but I want the shortest distance. So this formula allows you to calculate the shortest distance, which is what we want. So in order to use this, you need to convert to general form, plug in your values, and then you calculate the distance. These two little lines, for those of you who haven't seen it before, these mean absolute value. That means everything, no, not everything. Your solution is positive. So we'll take a look at what this means. Just a quick preview. When I do this addition, if it's negative, it doesn't make sense to have a negative distance. So those two lines just say, okay, well, you're going to turn it to positive because distance has to be positive. Okay? So let's start some examples. All right. Calculate the distance between this and this. So your distance, you have a point, you have a line, ax plus by plus c all over the root of a squared plus b squared. Now, the first thing you would do is convert this into general form, but in this case, we have general form, so we don't need to do that. And now we just plug in our values. So this is my x, this is my y, this is my a, b, and c. So I have 3 is my A, 2 is my X, 4 is my B, -1 is my Y, and my C is -12. A squared, so my A is 3 and my B is 4. I then do within the bracket, I don't do these until the end, they're like brackets. So I have 2 times 3 is 6, minus, because we have 4 times -1 is -4, and we have 12, over, this is, if I put this together, it's 25. Six minus 4 minus 12 gives me -10. This is 5. Now these brackets basically mean that this 10 becomes a positive. And then I can divide by 5, giving me 2 units. We're going to do this quickly because we're running out of time here. Calculate the distance between the parallel lines, this and this. So in this case, it doesn't say, and in a lot of problems, it's not going to say use distance point to line. You're just going to be expected to know it. So here, the distance between the parallel lines. I have 2 lines that are parallel, and I want the distance between them. So what I'm going to do is I'm going to choose a point, and I'm going to do that point to the line, because since these are parallel, that distance will never change. So for 1, I'm going to make my life easy. I'm going to choose x is 0. So 3y minus 6 is 0. So 3y is 6. So y is 2. So the point I'm going to use is 0 and 2. This line's in general form. So I say the distance is ax plus by plus c, all divided by a squared plus b squared. I plug in what I know. So I have that the a is 4 and my x is 0. My b is 6. My y is 2 and my c is 3. All over 4 squared plus 6 squared. So then I do my calculations. This goes away. So I get 12 plus 3 all over 4 squared plus 6 squared gives me 52 square rooted. If I put the 12 and the 3 together, that gives me 15 over the square root of 52. 15 is positive, so it doesn't really matter. If I get the square root of 52, I get 7.21. And I divide, I get 2.08 units. So just to end things off today, I just need you with me for a couple more minutes. I'm going to give you the instructions to do this problem. I want you to try it, and that's the problem we're going to start off with next class. So you need the area of the parallelogram. Area is base times height for a parallelogram. Yes, you could choose either general line because they're parallel. You could have done that with the other line, didn't matter. So here, consider the parallelogram. We need the area, which means we need the base. Well, if we use this as a base, we can make the height by extending from here to this line at 90 degrees. So step 1, find rule of line AD in general form. 2, find distance B to AD. 3, find distance A to D. 4, solve for area. So we're going to start off with this problem, but I really, really want you to have tried it. Just a couple of things before I let you go. The assignment for today has a lot of half planes, and we didn't talk about half planes together. If you know what you're doing, feel free to start it this afternoon. I'm going to wait until Wednesday to look over it, so you'll have tomorrow as well to work on this assignment before I give you feedback on Wednesday. So there's time for that. Just skip the half plane questions for now and go back to those tomorrow. On the handout, there are 30 pages worth of handouts. Sorry. Step 2 is find the distance B to AD. So finding this distance. So that's your point to line that we just did. So just to wrap it up, like I said here, you have this handout. There are 30 pages. I'm not expecting you to do it all. Focus specifically on the questions that have to do with distance, point to line. Anything you see that's symmetric or general, focus on those two. Like you have some general stuff there with parallel, perpendicular. You have this one here that's a symmetric one. These ones here. So you can do all of those. The rest of it is just really good practice for analytic geometry. So here you've got another symmetric form. You go at the back, it gives you problems for analytic geometry that are part A, part B, and part C. 1 or 2 of them involve half planes, so don't do them. This is a really good practice for distance from a point to a line. And this is half plane, so don't worry about that. Okay, so just take a look at as many of these problems as possible. The solutions will be posted at 8 o'clock tonight, so you could take a look at as many of these as possible this afternoon. Like I said, don't do the half plane questions on the assignment. One last thing is here, you just got a new notification. Handout class 6, assignment class 6. Okay, I don't know why you didn't get that. Okay, in the other class, I'll make sure that you guys get it in a second. There's this helpful here. I gave you this paper. Basically, these are relationships to help you do analytic geometry questions. So if you're using an isosceles trapezoid, that means that you have parallel, which means you're using parallel slopes. And you have, once isosceles means 2 sides are equal, you're using the distance formula. If you're talking about a rhombus, you have 2 sets of parallel sides, so you're using parallel for slope. You're using distance because all the sides are the same length. So these 2 documents just give you some information about shapes and angles that might be helpful for you when you're doing problems, especially in the analytic geometry thing, because you have some problems that say, prove this quadrilateral is a right trapezoid, and you have to know which tools to use. So you can put whatever pieces of information from there you want on your memory aid. If there are any questions, feel free to email me. We'll see each other on Wednesday, and we'll be going over SIPROB and memory aid issues. Other than that, have a great afternoon filled with some math, I hope, and we will see you tomorrow at 10:30 sharp.